Very good morning to all. Today we are going to explain you about the authentic requirement and authentic function in the unit 4 in the subject of cryptography and network security. So first we have to know what are the possible kinds of attacks on the communication network. So that has been listed here. Number 1 is disclosure, number 2 is traffic analysis, number 3 is masquerade, number 4 is content modification. Number 5 is sequence modification. Number 6, timing modification, source and destination repudiation. So what do you mean by disclosure? Disclosure means revealing the message that has been kept secret only between two end parties, revealing to the third parties without any permission, without the authentication of the other two end parties. That is said to be an disclosure. Traffic analysis, when the third party is there sitting in my network and he or she is monitoring the entire network traffic. What is the traffic goes to, what are all the kinds of data transfer happens to be there in my communication network. So that is said to be an traffic analysis. The third one is masquerading. Masquerading tells that forging an identity is said to be an masquerading. So identity of another user, forging that is said to be an masquerading. Content modification, whatever text or data that has been sent between two end parties that has been modified by the third parties, compromising the security, is said to be content modification. And the fifth one is sequence modifications, altering the sequence of the messages. So that is said to be an sequence modification. Timing modification, delaying the message by creating a false congestion over the network. And source and destination repudiation is nothing but denying of an action that has been performed by the source and destination, is said to be an source and destination repudiations. So these are the possible kinds of attacks in my communication network. So in order to overcome these kinds of attack, message authentication is very important. What do you mean by authentication? Is nothing but knowing the identity of the user, to whom I am sending the data, from whom I am receiving the data. In simple words, this is said to be an authentication. Without any authentication measures that has been taken, I cannot transfer just my data or whatever it might be just like that to the other end parties. So message authentication is a procedure of verifying the received messages, whether it is from the alleged source or not, whether it is from the right person or not, and it has not been altered or not. Okay, so when I am talking about it has not been altered, I am also including the topic called data integrity. So the data should remain same in all the places. That is said to be an data integrity. And message authentication may also verify the sequencing and timeliness of the messages. So to provide this message authentication, a digital signature is an authentication technique that also includes measures to encounter repudiation by the source. So what do you mean by digital signature? It is analogous to a physical signature. Where do we attach our signature? Whenever we are enclosing that this information is true. Whenever we are saying that this is the right information, we are taking the responsibility. That is where we always enclose an digital signature to prove our own identity. Similar to that, here also digital signatures are generated to prove the identity of one person who has been sending the messages. So authentication functions, so it is a function that produces an authenticator. So how we are going to provide this authentication? This has been done using the three classes. Number 1 is hash function, number 2 is message encryption, number 3 is message authentication code. So hash functions, what is the role of hash function? Is a function that maps a message of any length into a fixed length hash value, which serves as an authenticator. So any kinds of message, it might be a various length, but it always generate a fixed length hash value, is said to be an hash functions. And second thing is message encryption. The ciphertext of the entire message serves as its authenticator. So next is message authenticator code. So function of the message and the secret key that produces fixed length value, where this fixed length value, verifying this fixed length value only we will be authenticating. So moving on to message encryption, we have already discussed about this message encryptions. So what do you mean by message encryptions? I am going to convert my entire plain text into an ciphertext in an illegible. What do you mean by ciphertext? It is an illegible form. So here we have two kinds of encryption techniques. One is my symmetric encryption, another one is my public encryption technique. So what is symmetric encryption? When a same key has been utilized for both encryption and decryption, this is said to be an symmetric encryption. And public key encryption, so when I am using different keys for the encryption and decryption. When sender uses private key to encrypt the message and public key to decrypt the message, that is said to be an public key encryption. So a message have come from A, which has been possessing a private key. Okay, so two different keys has been involved over here. That is said to be an public key encryption. So what are all the basic uses of message encryption that has been depicted in the diagram? The very first diagram, we have a normal public key encryption where the same key has been utilized over here. For a message has been generated, it has been encrypted with a key. The same key has been utilized for decryption over here also. So this is symmetric encryption where we have maintaining the confidentiality. And second thing is public key encryption. Public key encryption, we utilize two different keys. So two different keys. So in the encryption part, we are using the public key of the sender, and the receiving part we are decrypting using the private key of the message. And then the third one, it encloses public key encryption along with the signature. So whenever encryption has been done with the help of your private key, it always generates an signature, not an ciphertext. So this is so this signature for a message has been generated, and then it has been sent. The receiving and decryption using the public key has been done. So the fourth diagram is public key encryption along with all these combinations. So and signature has been generated, and then again encryption has been done along with the signature, and then it has been transmitted. So since it has been the entire signature has been encrypted, in the receiving end we have to perform decryption, and then we have to perform strip the signature, and we have to retrieve back my message. These are the basic uses of message encryptions. We will see the other basic uses of hash functions and remaining things in the next upcoming lectures. Thank you.